Hi everyone, this is Sasi, and today we are going to talk about NodeJS. We'll basically try to develop a backend server in JavaScript. Okay, so this is fifth webinar in series of total 5 webinars, and we have already seen intro to web development, introduction to front-end development, followed by React, using React specifically for front-end development. In previous webinar, I talked about the backend development and various technologies involved in that in general, right? In this webinar, we are going to talk about Node.js specifically, and we'll also try to make a very small server. We are constrained by time. We will have to kind of try to fit all this within 1 hour, 1 hour, 15 minutes. So we'll take a very small example and we'll try to develop that backend server, also try to put it live, just to see end-to-end perspective on how you start developing a web server and how you finally go live with it. Okay, so the highlights for today are going to be what Node.js is, basics of JavaScript, some basics of JavaScript, even though we would have already talked about JavaScript in a couple of first two webinars, but we'll still see a small amount of JavaScript basics. Okay. In that, we are going to talk about objects, JSON specifically, because JSON is something that we use heavily for data interchange between two computers. And that's something that we'll be doing over here, right? We'll develop a front end, we'll have a front end, and we'll develop a back end, and both front end and back end must talk to each other and exchange data with each other in some format. JSON is the de facto format that we will be using. Along with that, we'll also talk about modules. Now, modules have not always been a part of JavaScript. Recently, they became kind of integral part of JavaScript, and Node.js was one of the perpetrators behind this. Node.js was one of the reasons or one of the platforms that popularized this concept of modules, right? So we'll look at modules the way Node.js envisioned it. Since then, it has been worked upon multiple times, and today a different kind of modules called ESM modules is accepted as standards, but CommonJS modules, which is used in Node.js, is still available and is still the preferred and default module system of Node.js. Followed by that, we will talk about Express or Express.js, which is an MVC framework built on top of Node.js for helping developers develop a backend site or an API website very quickly. Okay. We'll take a break from the PPT at that point, and we'll go try to build such a server ourselves, and we'll also try to deploy it to a PaaS provider. If you remember, in last webinar, we talked about something called Platform as a Service. It's a type of cloud service provider. We'll use a PaaS provider called Heroku, and we'll try to put our website live during this session. For those of you who are viewing this after the webinar has ended, I can't promise that it will remain live forever, but it should be live for next 30 days or so. After that, if time permits, we'll also try to add database linkage to our app. Database is absolutely required, but I'm keeping that after deployment so that we at least have some sense of completion after we have deployed our website. And finally, we'll talk about authentication and authorization. We will not be able to implement it in our code most probably because of time constraint, but we'll talk about it. What are the best practices to follow for authentication and authorization? Okay, so let's start with Node.js. What Node.js is, how it came to being, and what it is used for. In layman's term, right, Node.js is not a programming language at all. Node.js is a program written on top of another library called V8. Okay, V8 is the library that is used by Chrome browser. You might actually be using Chrome right now to view this video on YouTube, right? V8 is a part of Chrome browser. It's a library inside the Chrome browser, which is used for running JavaScript on inside Chrome. Like whenever a website tries to download some JavaScript and run it in Chrome browser, behind the scenes, V8 is a library that is actually taking that JavaScript code, compiling it, just in time compiling it, and then executing it for the browser, inside the browser. Someone in a company called Giant, this was a common concern everywhere, that since web developers have to learn so many different programming languages, right? And JavaScript is a must-have language on that resume, on a web developer's resume. So how could we take JavaScript and make it run on server side, outside of browsers? And for that, good people at Giant, what they did was they took the JS engine out of a browser. They selected V8 for various reasons, because it was already very modern, already very complete, and kind of bleeding edge in terms of features that were available inside V8, right? So they took V8. They could have taken other browser engines too, from uh, Firefox, for example, but V8 is what they went with. So they took V8, they added extra functionality on top of V8, and they created a program, right? This is just a Node.js is just a program which can take JavaScript code and execute it and provide output. This just the same way that a Java program can execute Java code. Now, this confusion about between the program and the programming language comes because a lot of programs or a lot of programming languages have a compiler or interpreter or runtime environment by the same name as the programming language. For example, PHP is a programming language, as well as PHP is a program which runs programs written in PHP programming language. This can get slightly confusing even to say. So in case of JavaScript, at least, that's not what they did. The program which executes JavaScript is called Node.js, right? Unlike PHP or Python or Java, where the name represents a programming language as well as a program that can run code written in that particular programming language. All right. So Node.js provides these features. It allows us to run JavaScript outside the browser, obviously. Along with that, it adds networking capabilities to JavaScript, and it adds file system access to JavaScript. Now, JavaScript in browser is also able to do networking. In one of the previous webinars, you would have seen you could make API calls from JavaScript inside browser. But that networking capability is not technically part of JS engine. That networking capability has never been part of V8, for example. That networking capability has always come from different part of a browser. On the right-hand side, if you see that graphic, it shows out, it displays some of the most common parts that some of the most common cogs and wheels that most of the browsers must have. A browser must have a user interface where you see the address bar, the reload button, the go button, and all the extension and whatever that you have, right? Whatever you see in the browser window is the user interface that allows you, the user, to interact with the program browser, right? Behind the scenes, there is a browser engine, there is a renderer, there is networking engine, and there is JS engine. All of them together provide the functionality that is required of a browser, that is expected of a browser, right? Since networking is required in so many other parts apart from JavaScript, most browsers kept networking code separate from JavaScript code. And for that reason, people who were developing Node.js, they had to add the networking capabilities on top of V8 inside Node.js itself, right? Along with that, the file system access is also provided natively by browser, and JavaScript typically does not know about file system at all. So again, that extra functionality had to be added because any decent server-side programming language would be expected to interact with file system, right? To create a temporary file, to read an already existing file, and so on and so forth. So file system access had to be added on top of that. Along with that, obviously, interface to OS, again, browsers, the JavaScript code in your browser that runs in the browser, it's kind of limited in scope. Not limited in functionality that it can achieve, but limited in scope. For example, JavaScript in browser cannot talk to your OS directly. It cannot tell OS that, okay, switch on the camera. That has to be like browser must be there in between. But a server-side programming language would be expected to talk to OS directly, and that interface to the OS, that layer, compatibility layer that connects JavaScript code to the actual operating system, had again to be built inside the Node.js, right? Now, all these things are no common feat. They're not small achievements. They are actually huge achievements. But one of the most strong reasons why Node.js became so popular is because of its support of modules and because of advent of NPM, right? What support for modules means is Node.js allowed any developer across the world to write some useful code or write some code which they think will be useful and then put it out on internet for anyone else in the world to use. This takes the concept of libraries to a whole new level, right? There are literally millions and millions of Node.js libraries that we call Node.js modules available on internet, almost anything that you can think of. Almost certainly there would be a library, there would be a node module already written by someone for that exact purpose, and you won't have to duplicate the efforts. You'll simply be able to use that module, download that module and use it in your code without writing even one line of code, one line of extra code, one line of duplicate code, right? This module support has been a tremendous point in favor of Node.js's popularity, right? NPM is an ecosystem that developed around this module support. NPM ecosystem basically allows you this functionality of uploading your code to NPM repository, and then your users, right? Whatever code that you have uploaded to NPM repository, whoever wants to use it, they could very well search for whatever they need and then find your code and then download it and then use it. So, and you could think of NPM as a Google for Node.js code, Google for open source Node.js code that's someone else has written and shared. Okay. As promised, let's talk about JavaScript in a very, very brief manner. Like, this is by no means a complete introduction to JavaScript. We are only going to talk about the specifics that we are going to be immediately using in our code. Okay. Now, one of those things is objects. Objects are very basic concept of JavaScript. Like everything else in JavaScript is pretty much built around objects. And in JavaScript, objects are a collection of key value pairs. Okay, so an object, you could think of it like a container. You could think of it like a box in which you can put multiple items, and each of those items will be a pair of key and value. Okay, key is typically supposed to be a known value and value is supposed to be a unknown. You associate an unknown with a known value. For example, if you wanted to create an object to represent a student, right? In such an object, you could have a key like name and its value could be Shashi in my case, or Neha, or Jane, or John, or so many other names, right? So whenever you wanted to extract the actual name of the student from this object, right, you'll use the known key called name, and you'll try to look for the value associated with your known key name, which will get as a C or whatever was stored, right? Now, there are multiple ways of, just because object is so basic, there evolved multiple ways of creating objects in JavaScript. Now, the first one and most common one by far is the literal syntax that you see on left hand side box, right? The literal syntax is the way for creating an object simply by using curly braces. So if you simply write open curly brace and close curly brace, that creates an empty object, empty container in JavaScript, right? You can add n number of key value pairs to say that, okay, create an empty object and then add these key value pairs directly to the, like immediately after creating the object, add these key value pairs to my object, right? The second that you see is object constructor. In this case, you create an object by instantiating a object class. Now, technically, JavaScript does not have classes. I mean, JavaScript did not have class till recently. Now it does have class syntax, but JavaScript has always supported object-oriented programming. Just that JavaScript deals with objects rather than classes. There are no, even the templates that are used for creating classes. If you are familiar with some of the object-oriented programming, right? Then classes are considered like a template for creating objects, right? In JavaScript, even those templates from which we create an object are objects themselves, right? So we have so-called class called object, and we can instantiate it using the new keyword to create an actual object out of it. And on this object, we can add as many key value pairs as we want by using the dot notation. Right. So where obj equal to new object creates one object, stores it in a variable called obj, and then to add one more key on top of this object, right? Inside this empty object, we'll just say reference name, variable name, dot whatever key that we want to store. For example, if this object was supposed to represent a student or supposed to represent me as a person, right? Then it could be where person equal to new object and then person dot name equal to Sasi, right? In that case, basically object will have one key called name and its value will be Sasi. Okay. The third option is creating a constructor function of your own. Do note that in second option, we were using the object constructor for creating object constructor, something that already exists in JavaScript. By instantiating that, you can create a generic object. But if you absolutely wanted to create a class, right? And as I said, classes are a very new addition. I've not even talked about that in all these presentations, because behind the scenes, there are no classes. There is only prototypical inheritance. So I have constrained myself to the internals and didn't add the syntactic sugar of class keyword, right? So in this case, in the last option, we are creating a constructor function of our own. Instead of creating an object out of generic constructor that is already available, we are creating our own constructor, right? And I've called it foo. You could call it person, right? If we were expecting this class or this constructor to represent a person, right? You could name it person, and then inside that you could assign a name for them, something like that, right? So in this case also, in all these three cases, by the way, the final object will be same. It will have one key called foo and its value will be bar, right? But we have achieved the same objective in multiple different manners. Each of them has its own utility, except the second one. We don't use that. Never ever use that, although it's possible, and I've highlighted that because you might end up reading code from someone else who has already used it, right? But we don't typically instantiate it. There's no objective benefit to using the object constructor over using the literal syntax, right? So the constructor thing only comes into picture if you want to create your own constructor. Otherwise, just use the literal syntax. Fair enough. Do stop me, and if you have any questions, right, just let me know. I'll pause and I'll answer your question before we move forward. Okay. So moving on, this is what objects are in JavaScript. Let's talk about JSONs. JSON stands for, it's an acronym. It stands for JavaScript Object Notation. It's a data interchange format. How do I explain? Okay, so data interchange format basically means it's a format for serializing data. It's a format for converting data into bits and bytes that can be transferred over network, right? It's serializing data in such a manner that someone else could look at the final bits and bytes and reconstruct the original object back on their computer. Now, if you think about it, when you create each of these objects, right, in whatever manner that you choose, right, in any of these three manners, if you create an object, that object is created in your memory. That is, that object is created in your RAM. And as you know, RAM of one computer cannot be accessed by other computer, right? If two computers need to communicate with each other, there must be a way for taking data from your RAM and then converting it into such a manner, converting it into some common fashion, so that you could transfer it to the other computer, and other computer will be able to reconstruct the same object in their own RAM, right? Because your programs can only read data or store data in RAM. They cannot read data from anywhere else. This is true even of your hard disk, by the way. Your programs cannot read data from hard disk. When your program tries to read an image, for example, it first tries to load the image into RAM and then read it from there, and so on and so forth, right? So that stays true for JavaScript too. All these objects, if they have to move from one computer to other computer, right? For example, from your backend server to your front-end browser, in that case, there must be some common way, some standard for taking data from server's RAM and converting it into some format which the browser will be able to reconstruct in their own random access memory, right? JSON was proposed as one such option by Douglas Crawford. What he said is that we already use these curly braces for representing objects in JavaScript, right? And our objects are always of the form key value pair. So why couldn't we just do the same thing in a text file? If we could do that in memory, we could potentially do the same thing in text file, right? So he envisioned data interchange format in which there will be two different types of composite structures. I ended up saying it made of two different structures. It's not two different structures, it's two different types of composite structures. Composite structure would mean something that is made out of smaller blocks, and atomic structures would be something that is indivisible, something that is unique, it's an own right? Which cannot be divided into smaller bits and pieces. So two composite structure, one represents a object, which is same name value pair that we talked about before this. And second one represents list of values, list of items, right? It could be list of objects, list of strings, list of numbers, booleans, anything, right? But second composite structure is a list. First composite structure is a collection of name value pairs. Now, you could always wonder why only these two, why not some other complicated data structure like linked list and so on and so forth was selected. They did not, because their aim was to make it universal, like completely universal. Any two computers should be able to interchange data in this particular format. And when your aim is to be universal, and there are so many types of computers out there, there's Mac, there's Windows, there's Linux, and even among these two operating systems, your processor could be running a PowerPC, it could be running ARM or Intel processor, and so on and so forth, right? There are just too many variables, right? And your program could be written in different languages too. So to take all of that into account and ensure that JSON is not just for JavaScript, instead it can be used in any programming language on any computer, right? They went for very universal data structures that are available in almost all programming language on all type of systems, right? And finally, they settled on these two composite structures and plus the four atomic structures that I have mentioned below: strings, numbers, boolean, and null, right? There can only be these six type of things in JSON. There cannot be anything else, but you can always use these six things to represent something else. For example, there cannot be a class called customer or object of type customer in JavaScript, in JSON. But if you see on right hand side, I have already tried to represent a customer over here. There is a object on top level which has one key called customers. Its value is array. That array itself has two values, basically two objects, each object representing a particular customer. right? And each customer has name, age, and a Boolean value called whether they have added card to their profile or not, so on and so forth. So basically, JavaScript is so basic that you can fit almost any use case back into. Sorry, I didn't mean JavaScript, I mean JSON. JSON is so basic that you can fit almost any use case back into JSON. You can serialize almost any type of data into JSON. And based on the protocol, on the other side, you'll be able to read this JSON and create the object back in your memory, right? As I have already highlighted, that is not limited to JavaScript. It could be any programming language whatsoever. Okay. Some of the programming languages that support JSON out of the box are Python, PHP, Java, not out of the box, but there are there is very good support for JSON in Java now. And any other programming language is almost certain to support JSON out of the box without need of any extra library. Excuse me. Okay. So moving on, let's talk about another and last JS construct called modules. Modules are the conceptual modules. For now, let's at least keep them conceptual. Modules are the conceptual building blocks of a JS program. Modules are basically supposed to be a self-contained unit which defines what functionality, or which is aware of what functionality it wants to provide. Okay, so for example, let's say you wanted to provide someone, or if you wanted to provide the functionality of being able to calculate sum of two very large numbers, for example, right? Something very simple. Calculating sum of two numbers would be very easy. But let's say you wanted to write that in a library format. Okay. Let's say that to calculate a sum of two very large numbers, right, you needed two different functionalities. One was parsing the very large number out of a string, and second was actually adding up the two large numbers, right? Now, your library might need 100 different functions to achieve these two things, but you want to keep your contract very clear. Even for your library, you want to keep your contract very clear that when you try to use this library, you'll get one function, just one function. And to that one function, you will be able to provide two numbers. It will return the sum of those two numbers. How many functions you created internally to achieve that objective, it's completely up to you, and any external person will simply not be able to see those internal details, right? Any external user of your library will not be able to see the internal details, right? This is so much in line with the concept of data hiding and abstraction that object-oriented programming has been preaching forever, right? But it's kind of a different take on abstraction and data hiding than what object-oriented programming preaches. In case of modules, both of them are achieved. The data hiding and abstraction is achieved, but there is no class created per se. We just hide everything by default. Anything that is created is hidden by default unless you choose to explicitly export it, explicitly make it available to external people, right? Technically, just give me 1 second. Yeah. Technically, any file that you create in JavaScript can be considered a module. Okay. But you could also put a bunch of such file modules into one folder and then call that entire folder as one single module. And Node.js will automatically look for index.js in that folder, and then whatever is exported from index.js becomes the export value of that particular module, right? So yeah, you could call a bunch of files also as a module, or individual files also as a module. So 5 modules combined together form another module, kind of like Lego pieces, right? So if you combine 5 different Lego pieces to pick one big Lego piece, it's still a Lego piece, right? It could be combined with other Lego pieces. Modules are kind of similar. Now, once you're satisfied with your module, right, and you think that it provides some generic functionality, you could potentially publish it to NPM and allow anyone who wants to use it to be able to use it, to download it and use it. There is no restriction. Anyone in world can publish their code on npm. Okay, moving on. Express is a library, as I said, built on top of Node.js. Express is a, in very simple terms, Express is a node module. Express is a node module written by someone and published on npm, right? That you could download and use it inside your code to build a very sophisticated web app and or API without writing too much of the setup code. At least most of the setup will be taken care of by Express for you. You'll only be expected to write the exact logic, exact business logic of what you're trying to achieve. You won't be bogged down by writing rest of the boilerplate code, is what we call them. Boilerplate code is the basic code that you must write in all applications to just start it to run, right? For it to get to the running point. So you don't need to write the boilerplate code. Boilerplate code will be kind of auto-generated, or it will be inside the Express. You'll simply be able to include all that code in your program. Right. We will see an example of Express very shortly. Right. So I presented this code in the first webinar that we had, where I was trying to explain how easy it is to build a web server in Node.js. Right? All we are doing is fetching in the inbuilt functionality of HTTP library, which is present inside the Node.js itself, right? And we are telling HTTP library that, okay, go ahead, please create a server for us. And whenever server gets a request, right, from a client, execute this method. Simple as that. Whoa. And then at the end, we were telling that, okay, go ahead and start my server, start listening for connections from browser on port number 8080. Right. Let's try to run the server. Okay. Let's try to build this very simple server, and then we'll add more and more functionality to it, and we'll take it from there. Okay. So this is something called VS Code. This is the development environment that I choose to use. This is not the only one. There are so many other good editors and good IDEs available out there. I personally use VS Code because of its, it had just enough. Like, it's not bloated with too many things, and everything that I need, it simply happens to be here. So it's just good enough for me, and so I use that. But feel free to explore multiple different editors and IDEs to figure out what suits you best. Okay, so what I'm going to do is first create a new file. Right, let's start from that. I'm going to keep my terminal small. Also enables syntax highlighting. Okay, so the code that we had written there is first get all the functionality from HTTP library, and then tell the HTTP library to create a server for us, right? Providing it a function to be executed every time a request is received by the server. Right, and the final step was server.listen, in which we are basically telling OS, right, to start our server and start listening for connections from on the server, right? So if you think about it, a couple of things that we talked about, couple of extra things that were added on top of V8 inside Node.js, right? We have already used, for example, HTTP core networking. This was added on top of V8, right? Server.listen, this is basically a direction to operating system. Finally, whatever request is received by this computer, right, is controlled by OS. A program will almost certainly never have a control over that. A program must tell operating system that, okay, start listening for any connections that you might receive from other browsers or other programs. And if you do receive a connection with this very unique identifier, right, 8000, forward it to me so that I can handle it. So this is this program that we are writing, telling operating system that any request that comes with this identifier 8000 to you, you should give that to me so that I can handle it, because I know best on how to provide that functionality. And I've already told our clients, the browsers, that if you want to get the functionality that I provide, connect to this particular computer, connect to this laptop on port 8000, right? We pretty much have our server ready over here, and this could have been much smaller too. If we absolutely wanted to, we could have written all this in one single line, something like I'll just write that, show it, but yeah, never write code like this. This one line on line number 9 will also do the exact same thing. It will get the HTTP, use the HTTP, use the functionality exported from HTTP to create a server, and immediately ask for operating system to start listening to port number 8000, right? It can be very useful to write code like this when testing it out, but so it's good to know that you could do this. But never write code like this in production, because other people might have to read your code if you are working for a medium-sized company to large company, right? There'll be so many people reading your code to make more changes on top of that, and always try to make their life easy and not more complicated, right? So yeah, write code which is extremely readable, even if it's a bit verbose and it takes more lines, that's okay. Okay, let's say server-test.js is the name we want to save it with, right? So our server should actually be started. It didn't do anything. Let's actually just send out some response, say response.end hello world. Right. So all we are saying is whenever you receive a request, we are teaching our server that whenever you receive a request, you need to send back hello world. Nothing else, just hello world. Right. So our code is created. Let's go ahead and start it. Okay. Can I do ls just to ensure that we do have this server test.js over here, and we are going to start this code using Node.js program. Okay. So all we need to do to start our server is say node space server-test.js. Server-test.js is the name of my file that I have created over here, right? So when we execute this, right, all this code is just text, right? So all this code will be read by the Node program. It will try to execute this code using the V8 engine. V8 engine will figure out that this code on line number 1 itself is trying to require functionality from HTTP. It will fetch all that functionality, create a server, and so on and so forth, everything that we have talked about. Now, what we'll try to do is try and go to the server, try and access our server from our browser. Okay, so let's go ahead and create an incognito window. Okay, let's see if I can hide it. Nope, I can't. Never mind. Yeah. So let's just go to our local computer's address, which is always 127.0.0.1. Okay. So when we say when we try to go to 127.0.0.1, right, our browser will basically try to connect to the same computer, try to connect to operating system on the same computer. But to our operating system, we have said, listen for only the connections on port number 8000, right? And that we didn't specify over here. Let's do that. Let's say that 127.0.0.1 8000. And if you see, we just got our hello world back. As simple as that. So we already have created a server which can say hello world to or hello to anyone back, right? Along with 127, this is the IP address of local computer. Along with that, you can always also use localhost. Localhost will also point back to your computer only. Don't worry about the font size. I had increased it over here specifically to 300%. We could do the same thing for our localhost also. Let's, yeah, similar size, right? So localhost or 127.0.0.1, with both of them will be address of your own computer. To test your server, you'll always use one of these addresses in your browser. Right. Okay. So this is our very, very simple server, right? But most of the servers do different things when you go to different paths on the server. For example, if it was Google, right, and we did something like news, you'd get like inside on the google.com, if you said google.com/news, you'd get the latest news listed down from Google, right? If you said google.com/images, you'd basically get a search field in which you'll be able to type some text, and based on that, relevant images will be displayed to you from all over the internet, right? Same way, you could go to google.com/search and you'll get the capability to search the entire internet. The common point across all this is that when you go to different paths on your server, right, when you provide different when you try to navigate to different path on a particular server, different things should be done. Typically, that path would represent what you want to achieve on the server, what you want to do on the server. But in our code, it might get very, very difficult, because every time a request is received, the same function gets executed, right? So you will end up with something like this. You'll end up with something like if rec.path, rec object represents your request that came from browser, response object represents the response that you are going to send out back to the browser. Both of them are objects, but they conceptually represent the request and response. Yeah, so you'll say something like rec.path equal to search. If it is so, then return res.end search for something, right? Else, if let's go news. Let's just say I don't have any interesting news right now. Some message, right? So that we can know that we are able to take decision based on the path on which request was received. For all other scenarios, let's just say res.end not found. Okay, let's restart our server and go back to the browser and refresh. Whoa. Sorry, I ended up using the wrong term. Yep. Okay, not path. Path is something that is available inside the Express. Like once we start using that, we'll have path. But without Express, we have rec.url, and we can check what URL the request came on. If the request came on /search URL, then we do something. Request came on /news URL, then we do something else. Otherwise, we simply say that we don't know what the user wanted, and I don't know how to service that request, something like that. The thing is, any decent program will have hundreds of such paths, hundreds of such URLs to be handled. And writing all of them in one single file is very, very, very difficult, right? Because it won't always be one liner, right? It won't always be just sending one string back. You'll need to do some processing before you can respond back. And so this function will become so huge, and your code will be completely unreadable and unmanageable. If you want to make even one small change, right, you'll need to read through hundreds of thousands of lines, or thousands of lines to even figure out where you make that change. And after you have made the change, testing will be equally more difficult, right? So typically we would not do something like this. Even though it can be done, we don't do something like this. Instead, we employ the use of some other framework on top of, which is built on top of all this that you see over here, right? Internally, Express will also use the same http.create server, and it will provide the same function, but it will allow you, the programmer, to write your code in much more meaningful and much more organized manner, right? So let's do that. Let's leave this code over here, and let's just create a small folder, mkdir script foundation. Let's go with that. Okay, so I just created a file called index.js. We will try to use Express over here for achieving the exact same thing. We'll still say whenever a request comes on /search, right? We'll still say the same thing. Whenever a request comes on /news, we'll still say the same thing, but we'll do it using Express, and we'll try to compare what are the differences between using Express and between using the low-level networking capability that Node.js provides, right? So let's also keep our server test open so that we have the comparison. Just the way we imported all functionality from HTTP library using the require function, we will import all functionality from Express library using the require function. Now, here's the deal. HTTP is an internal module. HTTP is a module that is present inside the Node.js itself. Express is not. Express is an external module. You must download it from npm, right? Now, npm, what I was talking about is this: npmjs.com/package/express. If we do that, we will land up on this page where we can see some details about how to use Express, but no download button, unfortunately, right? Clearly 13 million people have been able to download this, so there is some way of downloading it, but there's no download button here per se. Even if there was, that's not what we typically use. Instead, npm has a tool. It has a command which you can use for downloading any package that you want. Okay, let's just quickly run through this. And we are going to use the npm command for installing Express. Okay, sounds fair enough, right? In English, npm install Express. Npm is the actual command, install is the sub command given to npm, and Express is the parameter. This is basically telling npm to download the Express library from cloud, from internet, and then save it on our computer. That's it. We got Express. One interesting thing to note over here is it says plus Express. But below that, it also says added 50 packages from 37 different contributors, right? This is very interesting. If you think about it, right, we only wanted Express, but the makers of Express, whoever builds Express, right, they themselves were free to add as many dependencies as they wanted. So just to build Express, they used 100 other modules. This is truly the Lego example that I quoted. Each module is a Lego, and multiple of these Legos come together to make one bigger Lego piece, and so on and so forth, right? So Express itself has 49 other dependency. Out of these 50 packages, one is Express, obviously, right? Other 49 are the dependencies that either Express needs, or it's a tertiary dependency of a dependency of a dependency, and so on and so forth, right? We don't need to worry about all that. NPM handles that for you, and to NPM, all you need to do is tell that install Express. After that, it's NPM's headache to figure out what Express needs and what Express dependencies need, and so on and so forth. But if you are ever curious, you can always do something like this, npm ls, which will list out the entire dependency tree. So our application needs Express, which needs accepts, which needs MIME types, which needs MIMEDB, and so on and so forth. The list, it gets pretty nested. Right. So continuing with our example, we have our Express. Now, as I said, all modules export one thing or a set of few things, but set of limited things, right? One of the things that Express exports is a function capable of creating applications. What we call server over here is called application in Express terminology, right? So application is somewhat of an equivalent to server. It's not truly a server. It's more extensive than that, and that's why it has a different name. But typically, Express is used for creating applications. Okay. And this app has a bunch of functionality. Just the way, if you notice, one thing that we did not do is while creating a server, we had to provide a function which will be invoked whenever a request is received. We did not provide any such thing when creating the app. Even though I said app is analogous to server, we did not provide any function to handle that request, right? We'll get back to that in a quick minute. Before that, let's just start our server. The same way that we used to do, we'll say app.listen 8000, some port number. And yeah, let's leave this out for now. Right. So we got all functionality of Express, created our app, and we started our application. Within this, we must also tell this Express application what parts to handle and how to handle them. The one benefit over here with Express is that instead of providing one single function, we are free to provide as many functions as we want, right? If we have 100 different things that we want to be done with our application, with each and every request, we can add 100 different functions. So our requirement of like something that became necessary in our old model, right, is that everything must be written in same function, becomes nullified. You could spread your code out over multiple different functions. Let's just quickly see one way of doing that. Let's say app.get /search. So whenever URL was searched, we were sending this response, right? We'll do the same thing, just that it's done in a separate function. There's no if else condition. There are less chances of mistake over here. It will still do exactly what our other server did, but it is much more manageable code. If I simply ran this index.js that we have just created, right? Same functionality along with, but using Express, right? We should have similar results over here. When we go to slash search, we get search for something. When we go to slash news, we get, I don't have, like, whatever we put that over there, right? But when we go for anything else, it says cannot get whatever we put, right? Let's make that unknown. It says cannot get unknown, right? But in our old example, it would have said not found. Let's fix that, shall we? Let's also add a catch-all handler. Okay, now it says not found, completely as expected, right? So search, the news, then for everything else. So if the request came for slash search endpoint, right? In this stage, using these three dot get function invocations, right? We have basically registered functions to be executed for individual endpoints. Instead of registering one function to be executed for any request that comes in, right? Express is allowing us to register functions to be executed for individual endpoint, for one particular endpoint, right? And then using this special name called asterisk, we are also able to register a function which will be executed for all other endpoints, right? So if one of these two are added first, right? If one of these match, then request ends over there itself. But if none of the previously registered handlers match, then Express will end up calling this particular function. It's not as naive as I made it sound. There's more to it. But yeah, let's start with that. Another thing that Express does is allows you to add middlewares. Technically, everything that all the functions that we have registered till now are also middlewares, but colloquially, we call something like this a middleware. Okay, so when we said app.get slash search and gave a function, what we meant is that whenever a request is received as slash search endpoint, execute this function. When we say app.use and simply give a function without passing in any path, actually pass a path too. But for example, let's take the sample where we don't pass any path. What this means is that whenever a request comes, first execute this function, right? And then wait for this function to complete its work. And once it has completed its work, right, continue with the request. Try to find some other handler for this request, right? This can be very useful in scenarios like logging. For example, if you wanted to log a request, right, you want to say every time you got a request, you wanted to log something like a request for, let's say every time you got a request, you just wanted to put a log entry on your console that I've got a request for this path and nothing else. Just put a log entry, and rest of the functionality will still be handled by some other function which will be registered after that. You just add this function on top to do this one common objective. So everything that has to be done for all the different endpoints could be put in one of these common middlewares, right? And then the specific things that have to be done for one endpoint each, right? One endpoint at a time, that can go in the more specific middlewares or controllers, whatever you use to call them, and be handled like that, right? So logging, you'd want to do that for all the endpoints. So you'd put that in one common middleware for adding the log. Let's see how this plays out, okay? We go over here and refresh. Oh, you'll see the request stuck. As I said, Express is going to wait for us to tell them, wait for this middleware to tell Express that, okay, its work is done. And that can be, this middleware or any middleware can tell that its work is done, and Express should look for someone else to handle this request, is done by calling this next, the third parameter passed to a middleware, right? So what this middleware is doing is adding something on the console, making some log, and then calling next to tell Express that, okay, my job is done. I've not really sent out a response. I've not truly handled the request, but my job is done. So go on and find someone else to handle this request. And that's exactly what is going to happen. You see, as soon as I start the server, we get a log called got request for sets. That is happening because we had left this thing. Let's just quickly switch the port. Most probably I have ended up, yeah. Most probably I have ended up with a daemon process. I can kill that, but that will take time. So let's not even go there. I've just switched the port. To show you this, you'll see that it got a request for /search, and it also got a request for /favicon. Right? That's something that browser automatically sends out for all websites. But the point to note over here is the response is still search for something. That means the response was still sent by this particular function. But this middleware that we added for all, we executed for all paths, right? That also got executed. And this can be really, really powerful tool. You can now think of your entire web application as series of steps to be performed, right? Receive the request, then parse input from the request. If the user has provided some input, parse that in some proper format. If user provided JSON input, then convert it into object. I told you, right? JSON will need to be converted into object in RAM on the other side. So someone has to do that kind of function. You could write a middleware which will just check what kind of input client provided, what kind of input browser provided, and then convert it into appropriate object. Right. Another thing could be, we could write a middleware just to check for authentication, if the user is logged in or not. Based on that, set some flags so that all the other functionality, right, all the other endpoints that you have, do not have to run the complicated logic of figuring out whether the user is logged in or not. You just do the complicated logic one place, add it as a middleware, and just let it for every request, it will simply end up getting executed, right? That can be very, very powerful way of creating application. Okay, so I said Express is an MVC thing. We have not really used M or V. All we are talking about is C, controller, right? The views in Express, at least when Express was created, right? This was back in 2012, 13, I believe. At that time, MVC used to mean something entirely different from what it represents today. At that time, the views also used to exist on server side, but as you have seen in previous webinars, nowadays we write code in React or Angular or such, which run completely inside the browser. So views and controllers have kind of gone farther from each other, I would say. And typically, Express application today will not have the view part of it much, like it could have potentially, even using React. But most of the developers will not do that. Instead of using Express as MVC, they will use Express for building APIs, which can be consumed in their React application. Right. So yeah, let's quickly. I'm wondering whether I should try to put this application live or something else that we have that I created to run through. Let's just put this thing live. Since we wrote all this live, right? Let's just put it on internet. Right now, it's accessible only on my computer. By the way, it will not be accessible anywhere else, right? Uh, you do not know my IP address. Even if you did know my IP address, my router is going to block your connection, and you will not be able to reach this laptop, this particular laptop, and so you won't be able to connect to my server. But if you absolutely wanted to, right, it could be done. You could or I could configure my router in such a manner, and I could, so that the request coming to that router gets forwarded to my laptop, and along with that, I could give you guys my IP address to be able to reach my laptop. But that's not going to be very extendable approach or very scalable approach, as we have talked about in our previous webinars. So what we are going to do is use Heroku, a PaaS provider, for deploying our application. Let's just go with the sign-up flow. Okay, let me just put in my name. And I've used my email address so many times. What am I? Let's say hobbyist. What is my primary development language? I'm obviously not a robot. Okay, Google does not trust that I'm a human. Now touch. Okay, so it's asking me to verify my email address before before its services can be provided to me, right? Let me quickly go to that on my phone. Yeah, there we go. I'm trying to confirm my account. It seems to be complicated password requirements. Okay, there we go. Cool. So we end up over here at the Heroku dashboard. And what it's saying here is either create a new app or create a new team when you are collaborating, right? When you are creating a real team and all, real project or real business, you most probably want to create a team so that multiple people can collaborate. But for now, I'm going to go with create an app and name it Express Basic Test. I hope that it's available. Yes, it's available. Create an app. Okay. Now it's asking me one of two things. I can either use Heroku Git to deploy our code, or I can use GitHub to deploy our code. I'm gonna go with GitHub just to show you guys how to put your code on GitHub also, which is also very necessary part. So before we are able to deploy our code, right, we'll basically need to put our code in GitHub, whatever we have written over here, right, one single file, but we will need to put it on GitHub, right? So let's change track for 1 second, go to github.com. This one, I'm not going to sign up with a new account. Let's just go with mine. So if you sign up for a new account, right, finally you will end up on this same page. It will look different depending on what repositories you follow, or it will be empty if you don't follow anything. But the overall page should be similar. You should be able to click new repository to create a new one. Let's name it Script Foundation Express Test. Some name, right? I'm gonna leave it as public and create the repository. Now all I need to do over here is create an empty, like wherever we put all our code, right, this index.js, just create an empty repository over there by running git init and connect our local empty repository, right, whatever we have created over here, to the remote repository, remote GitHub account or remote GitHub repository that we have created with this thing. All we need to do that is git remote origin. Okay, so a command like this, git remote add origin, basically tells that we want to add a new remote server. The name of remote server is origin, and the address of remote server is whatever I gave over here, whatever we copied over from our repository here, right? Temporarily, all I'm going to do is some things you never want to send on Git, and I don't want to either, so I'll just exclude that. Node modules is the folder on which all your dependencies are installed, and you don't want to save your dependencies because they can be downloaded anywhere, anytime, right? So I'm excluding node modules. Apart from that, everything else we will be saving in our GitHub. If you see, we have 1, 2, 3, and 4 files. Index is the only one that has code, but rest of the files have supporting information basically. Let's add all of them. Since this is not about Git, I'm going to be slightly brief about how and what Git commands we are using. Right, so basically all these files that we had created, I have staged them. I've added them to git scas, and I am going to tell Git to basically save all of them. Okay, so Git says that it has created 1, 2, 3, 4 files. Right, let's also tell Git to save it on our server. Yep, go ahead. Right. If you simply refresh this page over here, right, on GitHub, you'll see that all the code that we wrote over there, apart from node modules, everything that we have over there is present here also. And we did not save the node module over here because the only dependency that we needed is Express, and the npm is smart enough to just save a file, save the everything that you install, right, all the dependencies that you need inside this package.json file. And wherever this code is going to be used, you can simply install all the dependencies. Why copy code that is simply not yours, right? If it's someone else's code and you can get it anytime, why even save it on server, right? It's just wasteful. So yeah, we have our code here on Git. There is just one minor change we need to make to this code to make it runnable on Heroku. That's it. So Heroku does not want us to run our server on 7,000 port. Instead, Heroku wants us to be able to tell the port to us. So Heroku will tell us what port to start our server on. So we are just going to honor that. We are going to pick the port that Heroku tells us. Only if it's not provided, we'll go for 7,000. Right. Let's also get that back on. Still the same cycle. Earlier, there were 3 extra files created. In this time, I have modified one file that was already added to Git. And Git is basically asking me if I want to save the changes, save the modifications that I have made to this index.js file. I just told Git that yes, please go ahead and save. And I'm giving a small description of what I have done. And the latest code should be over here. Process.env.port or 7,000, exactly as we expected. Okay, so now that we have our code on some common place, right, from where Heroku can access it. Heroku will not be able to take code from our laptop either. So we just put all the code in one common place called GitHub, and we'll tell Heroku that, okay, go ahead, pull code from my GitHub. Right, it's asking me for authorization, which is done, and let's search for script. Okay. So this is the repository that we created, right? Let's just click connect. And deploy branch. If you see all these logs, it's basically trying to install the dependencies and whatnot, right? Just the way we got 50 packages, it's also saying that it got 50 packages, and that's it, done. Your app is deployed. Because of these cloud providers, deploying apps has become extremely easy for us. Like, oh, nice. Okay, something went wrong over there. So like something went wrong with our code and it was not able to run properly. Let's see if we can see our logs. Yes, we can. Oh. Yeah, these are the things that basically Heroku is telling us that it does not know how to start our server and it needs us to tell the command that it needs to run to start the server correctly, right? Let's send this latest piece of code back to our server, back to our GitHub, and Heroku should be able to pull from there. Done. Let's go back here and refresh. Yes, better, right? Now we are getting not found because we have not handled the slash endpoint, the root endpoint. But if we go to slash search, and if I get the spelling right, then we'll get the exact output that we are giving from our code, right? /news will be handled in, okay, whatever code we have written. And for all of them, you'll see some log being put in from the middleware that you have, right? The got request for something. So for every request, our middleware executes first, and middleware, after doing whatever it needs to do, right, it calls next, telling Express that go ahead and find a better solution, a better middleware for handling this request. I have done whatever I needed to do, and I cannot handle the request anymore. Like if this function itself wanted to send a response, right, could. All it had to do was send a response and then never call next. Express would not know better. It would not look for any other function to handle the request, right? Okay, so we have been going on for about hour and a half, and there is so much more that I'd like to show, but I'll kind of hold off here, and I'll just show how we connect front end and back end. Okay, beyond this, it's all up to your imagination and some documentation that you'll need to see for Express and all. So what I'll do here is leave the information at this point and just run through how you can learn more on your own. Okay, so first thing is Express. Express is pretty well documented. If you just go to Google and search for Express.js documentation, right, you'll end up on this website, which has some use cases listed. Basically, consider it like the advertisement for Express. And then there is this API reference. Here's the entire documentation for Express, like every functionality that Express provides. It will also have examples on how to use Express and so on and so forth, right? Everything that we have seen till now. Like the way we created an application using Express, right? Here you go. There's an example for that on how to do that. The way we added endpoints to our Express application, there's an example to do that, right? App.get slash and then handle it somehow, and so on and so forth. All the functionalities that are available on app, all the functionalities that are available on request object. For example, we have used rec.path, but there are so many other functionalities that are already available on request, and we don't need to do anything special to get that, right? And same goes for response object also. There's something called router. I am not going to talk about that because some of it is already available on the application. You don't absolutely have to use router. But you can always go through that documentation and help yourself learn more about Express.js. Okay. Another very common use case for any application is connecting to database. And this is completely my personal choice. My personal choice for connecting to database is Mongoose, and the choice of database is MongoDB, right? Not everyone will agree with that. Not everyone who likes MongoDB will agree with Mongoose either. Everyone has their own preferences in programming world, and that's completely okay. But MongoDB as a concept is amazing. It's completely in memory and it's very high performant NoSQL database. So it's extremely fast, so to say. But there are other databases available which provide the same functionality and same performance. If you want, you can go for some of them. One such option would be Firestore, something available from Google, right? Mongoose is a library, object document mapping library, which is available for use with MongoDB. Okay, just the way I said that data or objects that are in your RAM cannot directly be accessed by someone else from on some other computer, someone else in their browser. The same way, the objects or the data that is inside your RAM, inside your computer, in your memory, cannot be accessed or transferred to database directly. It must be transformed in some manner. Most probably JSON. JSON is one option, but there could be other ways of transforming too. But the point is, it must be converted into some common format that the database would be able to understand. Mongoose does that. It basically allows you to define the relationship between the objects that you are going to create in memory and what that should look like or what that should be stored like inside the MongoDB database. Again, there is ton of documentation available for both of those on internet. You can get the Mongoose documentation on mongojs.com. Right? Again, the first page has only some information, maybe a quick start guide on how you start using MongoDB. But you can read document, like rest of the documentation will basically have you go through all the functionality which is available on the Mongoose. I would not recommend going through all of this at once. That can be very overwhelming, so to say. Instead, go through the startup guide and start using the MongoDB. Once you have started using, right, you'll discover new use cases. You'll need to store a new type of data in MongoDB, or you'll need to validate the data that goes in MongoDB, and then you could come back to this documentation and look for that specific thing. How do I do X, right? And that way you won't overwhelm yourself with so much of information, so much of functionality that Mongoose provides. Same goes for MongoDB. MongoDB also had very good documentation, but I would personally recommend using this cloud provider called MongoDB Atlas. Okay, so MongoDB Atlas is a SaaS provider, just the way Heroku is PaaS, right? It provides platform as a service. You give your code to Heroku, and Heroku will take care of deploying it and running it, and even HTTPS and all. I don't think I showed this, but the site that we just created has valid HTTPS certificate from DigiCert, right? And all this would have taken time. You could also have done the same things, most probably not for free, or it's possible for free too, but it would have taken lots of time to achieve the same amount of setup that Heroku did for us in like seconds, right? MongoDB Atlas is the equivalent on MongoDB front. This will basically create a MongoDB instance in cloud for free for some time, at least for basic uses, right? If you are a business and you have very high needs, right? Large database needs, then you most probably need to pay for that. But for basic uses, even MongoDB Atlas is free. You could create an account, your database will remain in cloud. You'll be able to access it from your local machine, your laptop, as well as from Heroku. So you could basically write your code to connect to MongoDB Atlas database instance and deploy it on Heroku. Like from Heroku server, the connection will go to MongoDB Atlas instance, and it'll all work out fine. Okay, so I'll leave it at that. This slide is almost self-explanatory, and basically lists out what to do and what not to do. One thing that I'd like to comment on is the second point on don'ts. Never ever store user's password. This is something that we don't pay enough attention to, and even as a newbie developer myself, I used to store password in database. Like, this is in college when I was learning, right? I would simply put the password in database. That made sense, no? Your user is signing up, and whenever the user tries, after sign up, right? Whenever the user tries to sign in, you'd want to check whether the user entered same password as original or not, right? The first time during sign up, if you say 1234 is your password, when the user signs in, they'll again enter 1234, and you'd want to validate whether they entered the same password or not. And the easiest option that one could think of for doing that is just store 123. When they sign up, just store whatever password they provided in database, and then whenever they come back, look for what password they had provided originally, and then based on that, whether they are equal or not, say success or failure. But that can be very wrong thing to do, because if you lose access to your database, right, if some bad actor, some hacker, for example, gets access to your database, they will know your user's password immediately. And this can be a bad thing, because a lot of users put same password on multiple sites. For example, your password on Facebook and Gmail could be same, right? So if password gets leaked from one even small service, which you rarely use, but you have used same password on multiple larger services, there could be very big impact to the user. And just to protect users' information and user security, you should never store their password. Instead, what you should do is convert their passwords into one-time hash. Okay, one-time hashes are basically mappings. You could take a text, convert it into a hash. Whenever you have the text, you can achieve the same hash. You can get the same hash from original text, but the other way around is not possible. So you can think of it like one to many mapping. Multiple texts will result in same random string. So based on the random string alone, you cannot tell which text it originated from, right? So you should always store hash of the password or hash of any sensitive information which does not need to be reproduced. Instead, only needs to be checked for equality. For all the scenarios, you should only store them in hash format. Some other sensitive information that you do need to retrieve, right? For example, credit cards should be stored after encryption and should always be transferred over HTTPS. These are two things that I'd like to highlight when you are building the system out. Uh, I hope this thing remains in the back of your head and you look up more on it and are able to build a safe and secure web app. Okay, that's about it from me. If you have any questions, do let me know in comments and I'll try to answer them as far as I can. So I'll run through the slides very quickly. Let me go to the just in case this helps you come up with some questions. Okay.